Grab your calculator quickly. Grab your calculators. Let's go to degrees. Go to degree mode on your calculator. So mode, make sure you're in degrees. And I'll just quickly explain what the cofunctions are. Cofunctions, sine and cosine go together. Tangent, cotangent go together. Secant, cosecant go together. But the idea is if you take the sine and cosine of complementary angles, you'll get the same output. So type in the sine of 20 and hit enter. So the sine of 20. What did we get when we did the sine of 20? 0.3. Grant.
0.3420.
Okay, something like this. According to the complementary, I should be able to take the cosine of 90 minus that, so we can look right here. I already did the sine of 20 degrees, so if I take the cosine of what? 70, what do you get there? What's the cosine of 70? 0.3420. Okay, that's all it is right there. Cofunctions. We don't do a lot of work with them. It's just a relationship in it. We'll do more work with this box also in the future, but here are your reciprocal identities. You guys already know those. But the point is, we don't have a cosecant button on the calculator. We don't have a secant button on the calculator. We don't have a cotangent button on the calculator. So if somebody asks you to do secant, cosecant, or cotangent, you have to use your reciprocal identities. So instead of typing in, we can't type in cosecant directly. We actually have to type it in like that. If you want to do cotangent, you have to type it in like that. Okay? Quotient identities, I already showed you this one. Tangent is sine over cosine. Cotangent then is reciprocal, cosine over sine. Pythagorean identities become more important to us in Chapter 5. No doubt you've heard about Chapter 5, but that's where we do it. Find the value of each trig function using trig identities when the tangent of theta is root 3. You guys feel like you could do that? Sure, we'll do it together. We'll do it. That's fine. One of the things that I'm going to introduce real quick. Well, make space. Right now, there are two places that every one of these triangles can be drawn. So we need to really get in a habit of doing that. So put triangles in those two quadrants. Because my answer, when I look at it, is root 3 over 1, right? So opposite, here's your theta. Could be there and there. It sits always between the terminal side and the x-axis. So my opposite can be root 3 and my adjacent can be 1. Or my opposite could be negative root 3 and my adjacent negative 1. Because both of them turn out to be positive root 3 when you do tangents. Find the missing side. Find that hypotenuse now. The missing side, however you do this, would be square root of 3 squared plus 1 squared, which is square root of 3 plus 1, which is square root of 4, which is 2. Now, some of you might be going, well, what's, in the third question? What happens when you square a negative?
You can't do it.
Positive, square a negative. Positive, so you get the same answer. Your hypotenuse will always be positive. Your hypotenuse will always be positive. Okay, let's do, are you guys feeling confident?
Yeah.
Trey, what's the sign?
The sign.
Sign, what's the sign?
the adjacent over the cosine.
Opposite
over.
over.
The opposite over.
What is the sign?
Opposite over. Oh.
I can't find
The opposite would be negative square root of 3 over 2.
Depending on which quadrant you're looking at, you will get root 3 over 2 or the negative root 3 over 2, right?
What's that thing in the middle? Or between
Theta?
no, I thought that was
Or.
line, but
Or.
that's or.
Oh, I'm sorry.
That's better.
What does that say? That is some or. It's like a squiggly line with a word.
Video is so good.
What's Jeff, what's cosine?
Cosine is so adjacent over hypotenuse. Adjacent would be 1 over 2.
Or,
Negative 1 over 2.
you know, it depends on which quadrant we're looking at, but in this case, it's either. So typically what we'll do is we'll give you some clues later on that would say, hey, just do it in the one quadrant. How about cotangent? No. Yeah. Let's go to cotangent next.
Adjacent over.
One over
Or-
three.
No, yeah,
Would it be negative 1 over?
that's what I meant.
Cotangent.
It's a
1 over square root.
Negative 1. Yeah, 1 over.
Oh
You're a rebel, man. Yeah.
Okay, multiply by.
So if I just write them down, I get 1 over root 3 and negative 1 over negative root 3. So I need to simplify those. So when you rationalize root 3 over root 3, you get root 3 over 3. And we do that one, you also get root 3 over 3. So that would be your answer. We could have done cotangent by just looking here, right? Reciprocal tangent, and then rationalize.
Did you just write one answer? Or
Yeah, 1 is fine. 1 is fine. Yep. How about secant? Which one do you do the reciprocal of?
Cosine.
Cosine. So I just bring these answers over. What happens? 2 over 1,
It's 2.
or 2 over negative 1, so it's 2 or negative 2. And cosecant. 2 over root 3 or 2 over negative root 3, which would be 2 root 3 over 3 or negative 2 root 3 over 3. One of those two answers. Trig identity. We do this really just to kind of show you what's going on in the box. When we get to chapter 5, we do more of these. Put a circle around this. Okay? So our goal is to take what's in the circle and make it look like secant. So what I can do is take my cosecant. What's another way of writing cosecant? 1 over the sine of theta. What's another way of writing tangent? If you look in that box, there are a couple ways we can write tangent. 1 over cotangent, or sine over cosine. So let's write tangent as sine over cosine. What can we get rid of? What's left? What's another way of writing 1 over cosine? Secant. So that's what they mean by simplifying your trig identities. So the point would be when you get to calculus, I would rather take a derivative of secant than take the derivative of cosecant times tangent. I mean, it's just more difficult, more work. So we look to simplify things. I believe that's an alpha. It's tough to tell, but or the fish-looking Greek letter. So cotangent you could write as, we're going to do this one, cosine over sine times sine. What can you get rid of? And what's left? Cosine of the fish thing, which is what we were supposed to get.
Wait, why is it cosine over sine?
I looked at your
Right, on the video, and
She
then
was
I'd have
about
to
to tell
give,
the fish word.
I would have to give you credit.
Fish.
I said you're wrong, so
Wait, I'm just wondering why it's.
either explain why you're wrong.
If you need to put sine over 1, then cross them off, top and bottom.
No, look.
Why is he wrong?
That's right.
Look at these.
I'm mad at them.
You probably did.
You remind me of fish. Your name would be William the Fish. You'd be goldfish. You shine like
What are
gold.
you talking about?
I don't know. I was
Just think I know what you're talking about, just be
I
quiet.
don't know what.
That's what I say.
I watched Nemo last night. That's what.
Video.
This is.
It's a good test.
First.
Maybe it's sweet as heck.
Nemo has
Alright, according to the safety sticker on a 20-foot ladder, the distance from the bottom of the ladder to the base of the wall on which it leans should be 25% of the length of the ladder. If I put the base of the ladder too close to the wall, what happens?
It falls over.
I start climbing it up and all of a sudden I tip backward. Or if I put it, a 20-foot ladder and I go 4 feet up on the wall, as soon as I start walking up, boom, it just goes straight up. So, what is this distance then right here? What's 25% of 20?
5.
5 feet. What they're asking us, one, what's the angle? What's the acute angle, which means less than 90? Acute is less than 90 degrees on the bottom of the ladder. So a lot of times they also might say angle of elevation. So they want us to find theta and how high up the wall will that ladder reach. So there are 2 things we can do in this problem. So let's do part A first. How are we going to calculate for theta? Now take theta and tell me what 2 sides you know. Not their numbers, what do we call those sides? This is going to be the hypotenuse, and this is the adjacent. So when you do trig problems, sometimes it helps you guys if you write those names down, because now what uses hypotenuse and adjacent at the same time? Or secant, but most of you probably will choose cosine. So let's do cosine of theta. That is the adjacent over the hypotenuse. Okay, so I'm going to double check that I'm in degree mode. So get into degree mode. How do we get rid of the cosine? How do you undo cosine?
Whatever.
The inverse. So we're going to hit second cosine of 5 divided by 20. We get about 75.5 degrees, right?
Oh, yeah.
So to get rid of it, we did the cosine inverse on both sides. Now theta is by itself. Now you can be in radian mode if you want, but the answer that comes back to you is not going to make sense. For most of you, 75.5 degrees makes much more sense. So that's why I was in degree mode.
Why would it?
So it's about a 75-degree angle with the ground. Then we're going to answer part B. How high up the wall does that go? What can you do?
Pythagorean theorem.
Pythagorean theorem.
Just 5 times.
H then is the square root of 20 squared minus 5 squared. This is one of the few times in pre-calc that we get an estimation or approximation for it. What is it? Say this again. I know the hypotenuse. So if you wrote it out, you would say h squared plus 5 squared
19.
equals 20 squared. So when the 5 goes over, yes, we're subtracting. What do you get? 19.3 feet. So right there, the expectation is, in just one quick problem, that you guys remember how to find angles using your right triangle trig, and you know how to find sides using your right triangle trig. Pythagorean theorem. Back to this one very quickly. Do not divide. You can't divide the cosine. Okay? You have to do the inverse on both sides. And make sure you're in degree mode at that point. Good.